Hello students, in today's video we'll be discussing some concepts related to haloalkanes and haloarenes which are necessary for solving multiple choice question. Haloalkane and haloarene are represented as Rx if the R group is an alkyl group, then we say that it is an haloalkane, and if R is an aryl group or aromatic ring, haloarene. So for example, CH3X, where CH3 is an alkyl group, it is a haloalkane, and benzene ring bonded directly to an halogen atom is a haloarene. Further, with respect to haloalkane and haloarene, we'll discuss its classification, preparation, and chemical properties. In classification, the first classification is based on number of halogen atoms present attached to alkyl group or aryl group, in that if it has one halogen atom, two halogen atom and more than two, we classify them as. If the alkyl chain or aryl ring has one halogen atom, we call them as monohaloderivative, two halogen atom dihaloderivative, and more than three halogen atoms, we call them as polyhaloderivatives. Similarly, now when we consider a alkyl halide, in case of alkyl halide, the carbon atom which is bonded to the halogen atom, or the halogen should be bonded to an carbon atom which is sp3 hybridized, then we say it's alkyl halide. And similarly, in case of aryl halide, if halogen is bonded to sp2 hybridized carbon atom, we say it as an aryl halide, or even alkyl halides. We'll see examples. So based on this, we classify them into compounds containing sp3 hybridized carbon halogen bond and sp2 hybridized carbon halogen bond. So in sp3 hybridized carbon halogen bond, the first classification is alkyl halide. So already we have seen that sp3 hybridized carbon atom bonded to halogen is an alkyl halide, and it can be further classified into three different types, and those three different types can be represented as, so first one CH3CH2X, second one CH3CXCH3, that is onto a secondary carbon, then next is CH3CCH3 CH3 and X. Now here if we consider, X is bonded to a carbon which is bonded to only one carbon atom, hence it's primary. X is bonded to a carbon bonded to two different carbon atom, hence it's a secondary alkyl halide. And X is bonded to a carbon atom which is bonded to three different carbon atom, hence it's tertiary, and this halide we call it as tertiary halide. Thus we say that alkyl halides are further classified as primary alkyl halide, secondary and tertiary alkyl halide. Next is allylic halide. Now in case of allylic halide, we need that we have a sp2 hybridized carbon atom which is bonded to a sp3 hybridized carbon atom, that we call it as allylic carbon, and if halogen is bonded to that sp3 hybridized carbon atom, we call it as allylic halide. Hence, we call such type of halides as allylic halides. Next is benzylic halide. In benzene ring, we know that all the carbon atoms are sp2 hybridized. They are equivalent. Now to this, if you attach a carbon atom which is sp3 hybridized, and to that sp3 hybridized carbon atom, if an halogen is bonded, we call it as benzylic halide. Next, compounds containing sp2 hybridized carbon halogen bond. They are of two types, vinylic and aryl. Vinylic is sp2 hybridized carbon atom having halogen directly bonded to it. So that sp2 hybridized carbon atom is vinylic carbon, and since halogen is bonded to it, it's a vinylic halide. Similarly, as already seen, to the sp2 hybridized carbon atom of a benzene ring, if halogen is bonded, we call the corresponding halide as an aryl halide. Next, we'll go with the preparation methods of haloalkane and haloarene, out of which these four are most important. First is Groves reaction, Darson reaction, Schwarz and Finkelstein reaction. In Groves reaction, you have studied it, but you don't know that it's Groves reaction. That is when alcohol react with HCl or HX in the presence of zinc chloride catalyst, they result in the formation of alkyl halide, and that itself we call it as Grove's reaction. Don't get confused between Lucas reagent, hydrogen halide, that is HCl with ZnCl2 is Lucas reagent. Here any hydrogen halide in ZnCl2 is Grove's reaction. Second is Darzin's reaction. So Darzin's reaction is when an alcohol reacts with, so here for Darzin's reaction we'll just consider what happens, that is when an alcohol reacts with thionyl chloride. The formula for thionyl chloride is SOCl2. It results in the formation of alkyl halide, and along with that sulfur dioxide and HCl as a product. Similarly, if we go with the next reaction, so alkyl halide is a product here. Now we'll go with by Darzin's method. Next we will consider Schwarz reaction. So for an Schwarz reaction, always remember that what is formed as a major product is fluorides are formed as a major product. So alkyl chloride or alkyl bromide, when it reacts with metallic fluoride like silver fluoride, it results in the formation of alkyl fluoride and a byproduct. If you use alkyl chloride, AgCl, if you use alkyl bromide, AgBr. So this reaction where fluorides are formed is Schwarz reaction. Next is Finkelstein reaction. In Finkelstein reaction, as already we have studied for theory classes, that same like alkyl chloride or alkyl bromide, if they are made to react with sodium iodide, they result in the presence of dry acetone, they result in the formation of alkyl iodide with a byproduct as NaCl if alkyl chloride and NaBr if alkyl bromide. So these are the four important reactions which we discuss for the preparation of alkyl halide. Remaining are also there. You can refer your NCERT textbook. Next we'll consider its chemical property. In chemical properties, there are, that is with metal, the reaction with metals. First is Wurtz reaction, that is when alkyl halide react with sodium metal, it results in the formation of higher alkane. Similarly, in fatigue reaction, aryl halides react with sodium metal. In the presence of dry ether, they form diphenyl or biphenyl. Then the third reaction is Wurtz fatigue reaction. In Wurtz fatigue reaction, a alkyl halide reacts with aryl halide in the presence of sodium metal and results in the presence of sodium metal and dry ether and results in the formation of alkyl benzene. Next, Grignard's reagent. When alkyl halide reacts with magnesium in the presence of dry ether, it results in the formation of alkyl magnesium halide RMgX, which is called as Grignard's reagent. Next, we'll go with its nucleophilic substitution reaction. So whenever any alkyl halide reacts with a nucleophile, nucleophile acts as a is substituted to halogen, and halogen is removed in the form of halide ion, which acts as a leaving group. So hence we call it as nucleophilic substitution reaction. So in the first case, when it reacts with aqueous NaOH, it is seen that OH is a nucleophile, hence the resulting product is alcohol. With ammonia, it gives you amine, that is primary amine. Then next reaction of primary amine gives you secondary, reaction of secondary gives you tertiary amine. With KCN, potassium cyanide, it gives you alkyl cyanide because it's ionic compound, and with AgCN, it gives you alkyl isocyanide because it's a covalent compound. And we'll discuss about SN1 and SN2 in detail. Similar to KCN and AgCN, the reaction of KNO2 and AgNO2 is also important. With KNO2, it will give you RONO bonding occurs through oxygen, and in case of AgNO2, it is through nitrogen RNO2. Next, we'll discuss about SN1 and SN2 in detail as they are very important even from your theory, for your theory exams, theory questions, theoretical questions like mechanisms can be asked. So we'll go through them, SN1 mechanism and SN2 mechanism. So this particular is an SN1 mechanism with example of tertiary butyl bromide. So it's seen that in this reaction with respect to SN1, that when tertiary butyl bromide is treated with aqueous KOH, tertiary butyl alcohol is formed. So there are two steps. First step is slow step. In slow step, tertiary butyl bromide undergoes ionization to give tertiary butyl carbocation and bromide ion. And the carbocation has a planar structure. So here we see that it is ionizing and you get a carbocation. And since it is a slow step, we can also say that it is a rate determining step. So this step is important for finding out the kinetics of a reaction, and hence the order of this reaction is 1 as well as molecularity is also 1. Step 2 is the fast step. The nucleophile from aqueous NaOH attacks the planar carbocation on either side to give tertiary butyl alcohol. So here from both the side, that is from front side as well as from rear side, the OH minus attacks the carbocation to give you a mixture of two different products with different position of OH. In one you see OH present on the front side and in another you see OH present on the right side. So these are two different products obtained. The given carbon is not a chiral carbon, but if at all the reactant would have a chiral carbon atom, then the product obtained would be racemic mixture, as the nucleophile attacks equally from both the side of carbocation, and racemic mixtures are optically inactive. Next we'll go with SN2 mechanism. So the difference between SN1 and SN2 is, in SN1 it is tertiary alkyl halide, in SN1 it's a methyl halide or primary alkyl halide. So we'll consider the reaction here, that is when methyl chloride is treated with aqueous KOH, methyl alcohol is formed. So it's a single step reaction. Nucleophile attacks the electron deficient carbon from the rear side, and when it attacks the electron deficient carbon from a rear side, a transition state is formed. Transition state, we also call it as activated complex, which is highly unstable because carbon is bonded to 5 sides, not completely but still. And then further it results in the formation of product which shows inversion in configuration. We say it as inversion in configuration due to the change in position of a nucleophile. Old nucleophile Cl minus is on right hand side, whereas OH on left hand side. So next we'll go with electrophilic substitution reaction. In electrophilic substitution reaction, there is Friedel-Crafts reaction, sulfonation, nitration and halogenation reaction. Whether it is Friedel-Crafts, sulfonation, halogenation or nitration, whenever chlorobenzene reacts with any of the reagents which undergoes electrophilic substitution reaction, it gives you a mixture of ortho and para product, out of which para is major and ortho is minor product. So Friedel-Crafts alkylation will give you two different product, one ortho and para will be major. Similarly, sulfonation also will give you two different product with sulfonic group on ortho and para will be major product. Nitration also gives you two different product, one will be ortho, that is nitro on ortho position and para position, and para is a major product. And halogenation also gives you halogen on ortho and para position, and para is a major product. So you can refer your NCERT for this reaction. Along with these, there are few more concepts which you should know, that are generally enantiomers. So you should know about enantiomers. What are enantiomers? Then you should know what do you mean by a chiral carbon. It is also called as asymmetric carbon, and even there is another name, that is stereocenter. All these three mean one and the same. So chiral carbon, asymmetric center, etc. Next you should know even about racemic mixture. So what is racemic mixture, how it is formed, you should also know. You may get multiple choice questions on racemic mixture as well as you should know about phosgene. So what is this phosgene, how it is formed, and along with that freons, as well as the structure of DDT, structure and preparation method of DDT. So here if we see chiral carbon or asymmetric carbon, carbon bonded to 4 different sites, or it is on by 4 different group or atoms of group, we call it as chiral or asymmetric carbon. And the property of forming non-superimposable mirror images, we call it as chirality. Next we will go with enantiomer. So enantiomers, we consider them to be optically active. So enantiomers are optically active isomers which form non-superimposable mirror images. Similarly, we will go with the next part, that is racemic mixture. Racemic mixture means it contains 50% dextrorotatory compound and 50% levorotatory compound, and the mixture of these two which gives you zero optical rotation, we call it as a racemic mixture. It is highly optically inactive. Next is phosgene. Phosgene is formed by the oxidation of chloroform. So when chloroform undergoes oxidation, it results in the formation of carbonyl chloride. So you should know it, that is, this carbonyl chloride is the poisonous gas which is formed due to the oxidation of chloroform. And here this itself we call it as carbonyl chloride, or we call it as phosgene, and this is a poisonous gas which is released due to oxidation of chloroform. So carbonyl chloride itself is called as phosgene, and phosgene is nothing but, as I said you, it's a poisonous gas, so you should remember these both names, carbonyl chloride or phosgene. Then next is freons. Freons are nothing but the chlorofluorocarbon compounds of collectively of ethane and methane. So freons, what are freons is also important for your theory. The definition of freons can be asked. So they are chlorofluorocarbon compounds of methane and ethane, and they are itself called as freons. Example you can remember, CF2Cl2. Next is DDT. So you should know the structure of DDT. DDT is prepared by using chlorobenzene and chloral in the ratio 2:1, and DDT is nothing but dichloro-diphenyl trichloroethane. Thank you for watching.